If the series of absolute values of the terms in this series converges, then this series here converges absolutely. Otherwise, we say that this series converges conditionally. And the series can also diverge. So for example, if we consider this alternating series, then we designate this term as an, and this term here we designate as bn, which is the absolute value of an. And therefore, we can check if the series bn converges. And if it converges, then this series here converges absolutely. If a series A converges absolutely, and the sequence B is any arrangement of the sequence A, meaning that we can rearrange and group the terms in A in any order, then the series B will also converge absolutely, and the sum of series B will be equal to the sum of series A. Let's determine if this series converges conditionally, absolutely, or diverges. Well, we designate this term in the series as an, and this term in the series as bn, which is the absolute value of an. And now we check if the series an converges conditionally using the alternating series test. So in this test we just check if bn is greater than 0 for all n, which is true. And then we check if bn is greater than bn plus 1 for all n above some integer. Well, as we can see, 1 on n is greater than 1 on n plus 1 for all n. So this is satisfied. And then we check if the limit as n goes to infinity of bn is equal to 0, which is the case. So in other words, so far, the series an converges conditionally. Now to check for absolute convergence, we need to check if the series bn, which is the absolute value of an, converges. Well, we know that this is a harmonic series, and that it diverges. So therefore this series converges conditionally.